Hi guys! So today we are going to be going over the AP Calculus 2015 FRQ question number 1. In this question we are allowed to use a calculator. So without further ado, let me read this question to you. The rate at which rainwater flows into a drain pipe is modeled by the function r, where r of t equals 20 sine t squared over 35 cubic feet per hour. T is measured in hours, and t is from 0 to 8. This pipe is partially blocked, allowing water to drain out the other end of the pipe at a rate modeled by d of t equals negative 0.04 t to the third power plus 0.4 t squared plus 0.96 t cubic feet per hour, for t is less from 0 to 8. There are 30 cubic feet of water in the pipe at times t equals 0. Now, we're going to be going over questions A, B, C, and D. So, enjoy the show!
Part A reads, how many cubic feet of rainwater flow into the pipe during the 8-hour time interval? T is greater than or equal to 0 and less than or equal to 8. So we have our equation, RT equals 20 times the sine of T squared over 35 cubic feet. And so we need to take the integral of that from the integral from 0 to 8. And you can do this in your calculator. So you go to the math button and press 9 for the integral. You put in the lower limit of 0 and the upper limit of 8, and then the equation, which is 20 times the sine of parentheses x squared. I can't do it. Oh, that's s. Okay, wait, we need to redo that. Find it in your calculator, you go to the math section and press 9 for your integral. You put in your lower limit of 0, your upper limit of 8, and then the equation, which is 20 times the sine of, I'm putting it in terms of x in my calculator just because it's easier instead of t, but it still refers to t, divided by 35 in your parentheses, and then that is dx, since that's the variable we're using, and press enter, and you get 76.570.
You're being filmed.
Mr. Calculus says that, I don't know what to say about this. Similar method to solve this problem. He said that r of t dt equals 76.70 feet squared, or feet cubed, over the 8-hour time interval. Students made a mistake in this question by using 30 in the integrand or adding it to the integral, or they used r of t minus dt as integrand. You get 1 point for the integrand and 1 point for the answer.
So question B reads, is the amount of water in the pipe increasing or decreasing at time equals 3 hours? Give a reason for your answer. So to solve this problem, we have to consider both the functions that are in this problem. So RT is the rate at which water is flowing into the drain pipe. And then D of T is the rate at which water is being drained out of the drain pipe. So if we look at this, it's asking for time T equals 3 hours. So we're going to take R of 3, and then we're going to subtract D of 3, because we're trying to get the amount of, is the rate of the water increasing or decreasing. So we're going to take the amount that's being drained out, subtract that from the amount that's being flowed in. So when we plug 3 into RT and then plug 3 into D of 3, and then subtract D of 3 from R of 3, we end up with negative 0.3136. Now, since this value is less than 0, we can conclude that the amount of water in the pipe is decreasing at time equals 3 hours. Another way to look at it is after finding R of 3 and D of 3, we see that D of 3 is larger than R of 3, so therefore more water is being drained out than water that's been flowing in. So therefore, the amount of water is decreasing at time equals 3 hours. So Mr. Calculus gives 2 different options to solving this problem. The first one, he offers an equation for the amount of water that's in the pipe. So for this, he does A of t is equal to 30 plus the integral of 0 to t rx dx minus the integral of 0 to t dx dx. And we need to find the rate at which the water is either increasing or decreasing. And And so we need to take the derivative of this to find the rate. So when we take the derivative of this equation, we end up with A prime of t is equal to R of t minus D of t. So we're looking at time t equals 3 hours. So then we're going to plug 3 into A prime, and we end up with negative 0.3136. Now this value is less than 0, so therefore we can conclude that the water is decreasing at time equals 3 hours. The rate of water is decreasing. And so then another way that Mr. Calculus offers to do it is to find R of 3 and then to find D of 3 and compare them. To find the amount of water, the rate at which water is being flowed in and the rate at which water is draining out. So we find that R of 3 is equal to 5.086 and D of 3 is equal to 5.4. Based on this, we can conclude that D of 3 is greater than R of 3. So therefore, water is being drained out at a larger rate, at a faster rate than water is being flowed in. So therefore, it is decreasing at time equals 3 hours. So there are 2 possible points to earn on this problem. You get 1 point for comparing R of 3 and D of 3. And then the second point comes for providing an accurate answer with the reason. And there's several different common mistakes that students make on this problem. One of them is that they miscalculate when finding R of 3 and D of 3. When they plug 3 into the equations, they have issues with their algebra. Another common mistake is that they don't connect the fact that R of t and D of t are both rates, and because of that, they end up finding an answer that has to do with the amount of total water in the pipe rather than the rate of the water in the pipe. Another mistake is that they don't recognize that R of t and D of t are rates, and so they take the derivative of R of t and the derivative of D of t, and then plug 3 into that, and that would give incorrect information also.
Time t on the interval 0 is less than or equal to t is less than or equal to 8 is the amount of water in the pipe at a minimum. Justify your answer. The first step of the problem is to find the equation that models the amount of water in the pipe at any given time t. So to do that, we take the initial value of water in the pipe at time t equals 0, which is 30, and then add the integral of 0 to t of r of x minus d of x, with r of x being the rate that water flows into the pipe and d of x being the rate that water leaves the pipe, dx. So this models, using this equation, you can find the amount of water in the pipe at any given time t. And so once we have this equation, that's like the base. The next step is to find the derivative of this equation, because setting the derivative equal to 0 will give you the critical points along with the 2 endpoints. So the derivative of this equation is actually just r of t minus d of t, and to find the critical points, you just set this equal to 0. So r of t minus d of t equals 0, and then from there we'll go to the calculator to show you how to find that critical point. So after we put the derivative of our function into our calculator, as you can see, it's in right here. This is just r of t minus d of t. After you put that into your calculator and you go to your viewing window, you can see that this is the graph of our derivative, and we know that the critical points are going to be when the graph of the derivative is equal to 0, and also the 2 endpoints of our interval. So to find the point at which the graph of the derivative is equal to 0, we can do second calc and then 2 for 0, and then use your arrow keys to select the left and right points to find the 0 in the middle. And you can see that this 0 is x equals 3.2716. Okay, and that's how we find our first critical point, which is a possible minimum, but we're not sure if this is the only one, since there are 2 other options the first one is the left endpoint, and the second one is the right endpoint. So now we're going to check for those other two. Okay, so we have two other endpoints that we need to check for to see which one is the minimum. So the first one is at 0 and the second one is at 8. Since our interval is 0 is less than or equal to t is less than or equal to 8. So the amount of water at time t equals 0 is already given to us in the problem because it says there are 30 cubic feet of water in the pipe at time t equals 0. So that's already given to us, but now we have to test for at time t equals 8. So to do that, we need to enter in 8 seconds into our original equation. So the first step is to write 30, which is the initial value, and then plus math 9, which is the integrand shortcut, and then enter in 0 as our starting point, and then 8 as our stopping point, and then our entire function, which is r of t minus d of t dt. But for the purpose of this, since our calculator is in x's, we can just use x's instead. So right now, I'll just write r of t minus d of t, which is okay. So as you can see, I've entered the entire function into the calculator, and when I press enter, you get this value, 48.5437. And as you can tell, we have so far 0, or at 0, there are 30 cubic feet of water in the pipe, and at time 8, there is 48.5437 cubic feet of water in the pipe. And then the only thing we have to do now is find the amount of water in the pipe at time 3.2716 seconds. Okay, so the final step is to test for the amount of water in the pipe when the time is equal to 3.272 seconds, which is the critical point that we found as a possible minimum on the graph. So to do that, all we have to do is take the function that we already have input in our calculator and then change the end point from 8 to our critical number, which is 3.272. And what this will find is the amount of water in the pipe at 3.272 seconds. So all we have to do is hit enter. And then we get at 3.272 seconds, there is approximately 27.965 cubic feet of water in the pipe. Okay, so there are 3 total possible points for part C. The first one comes from comparing or saying that r of t minus d of t equals 0. So you get 1 point for having this piece right here, which again is just the derivative of the function that we wrote from the beginning. And then you get another point for having your answer. The amount of water in the pipe is at a minimum at time t equals 2.72 or 3.271 hours. So that's another point right there. And then finally, you get 1 point for your justification, showing that 3.272 is in fact the minimum by comparing it with the 2 other endpoints, which is time is 0 hours and time is 8 hours.
So 2 common mistakes for this problem. One of them not acknowledging the r of t minus d of t equals 0, which really sets you up to finding the critical point. And then the next thing that people missed was justifying that this value is actually the minimum and comparing it to the other 2 endpoints.
Hi, welcome back. Remember me from the intro? Alright, well now we're talking about part D. So, part D asks us, the pipe can hold 50 cubic feet of water before overflowing. For times t is greater than 8, water continues to flow into and out of the pipe at a given rate until the pipe begins to overflow. Write, but do not solve, an equation involving one or more integrals that gives the time w when the pipe will begin to overflow. So, I have solved this for us on the board. So, our solution is d, for problem D, is 30 plus the integral from 0 to w, r of t minus dt equals 50. Now, why? So, 50 is when it will overflow. So we are looking for it to be set to 50. So I have done that right there. And then we are going to take the integral of these rates. So if you were to actually solve, because the problem doesn't ask us to solve the actual problem. We're just writing the equation, modeling it. So I've done that. Now, if we were going to actually solve for the time, then we would take the derivative and use implicit differentiation and all that kind of fancy calculus tricks and stuff, and we would be able to define the t in here. But that is a further, more complicated problem that this particular problem does not ask us to complete. Thank you for watching this video. If you like this video, make sure you drop a like down in this comment below, smash that subscribe button, and click that notification bell for future videos. Peace out, guys. What? You're so awkward, Bryce. Bryce, you want me to fight you? I'm coming at you right now. Alright. Did people miss? Common mistakes, part D. Okay. Ready? Go.
Okay.
Hi guys! Okay, so I totally just forgot that we have to do the point distribution, so we're going to be doing that right now. So whatever I said before, we're just going to screw that, and let's get ready for point distribution. So basically this is our original thing I already showed you guys like 2.75 seconds ago, but this is our solution. Now I'm going to talk about what you need to do, what part of this solution gets you the points that you deserve on your AP Calculus exam. So we get 1 point for writing the integral, okay? So 1 point. 1 point. Sick, right? And then we're going to get 1 more point for writing the equation. Cha-ching! Alright, so we have now completed this. If you're able to produce an answer that looks something like this, you will get both points on the AP Calculus exam for Part D of FRQ number 1. Now, before I forget to talk about, so we have to talk about one more thing, and that is what are some common mistakes. Now, I will talk about this to you guys so you guys do not make these mistakes on your AP exam FRQ, because you don't want to miss out on these points, right? You don't want to be kicked to the curb, right? Okay, so let me look at this up. I'm going to pull up my cell phone. Alright, so according to Mr. Calculus, some students use an incorrect initial condition or no initial condition. This is a big mistake. Unacceptable. You must have a correct initial condition to get the correct answer. Now, what else? Many students use constant limits or no limits of integration. So of course, we're talking about from 0 to w, right? So without that, that would also render your answer incorrect. Now, other students admitted the differential dt. I don't know why you would do this, but we're in Miss Louie's class. Miss Louie always makes us write the dt or the dx. So shout out to Miss Louie. Thank you for training us into good habits. Love you, Miss Louie. And so yeah, so that was pretty much the entire wrap down of this problem. It's also the wrap down of our entire Calc Cup video. So thank you so much for watching. I will see you guys in our next video, probably AP Calculus AP next year, because I'm probably not gonna pass this year. Jacob, no, I'm probably just messing with you guys. But be sure to drop a like down the video, subscribe to the channel, and smash that notification bell. Peace out, guys. I love you guys for watching. Thank you.